Is the screen visible?
Yes, sir.
Okay. So the finally keyword, this is the last keyword that is left over to discuss in exception handling. So we have already seen try, catch, throw, and throws. So coming to this finally keyword, the finally keyword is actually, when it is a keyword, we have to use it as a block, just like a try block and catch block. Even finally block will be there, unlike throw and throws. Throw and throws will not have any blocks, they are just keywords. Try, catch, and finally they are blocks. So we have seen try block and catch block. So we also have additionally finally block. This finally block is not actually mandatory to be used along with try catch block. But if at all, if you use that finally block in your exception handling mechanism, even though if there is no catch block also, the finally block will be accepted instead of catch block after the try block, right? So if you are using catch block, then you can write the catch block after the try block. So remember one important point: if at all, if you are writing a catch block, right, there must be a try block earlier, and try block must be followed by catch block only. So if instead of catch block, I can use finally block. Any one of them must be there. Either finally block must be there or catch block must be there. You cannot skip both of them and write only the try block. If you write only the try block, it is going to generate an error. So for every try block, there must either be a catch block followed by it or finally block. So if you look at this program, in this procedure A, after the try block, there is no catch block. Instead of catch block, there is a finally block. Okay. This is a class we defined with name finally demo. This is one of the method. Procedure A is one of the method, and it is a static method. It has a try block and finally block. Then there is another method, procedure B, and even this is also having a try block and finally block, no catch block. And the other third procedure, procedure C, this is also having a try block followed by a finally block. And coming to the main method, what we are doing is, after try block, we have a catch block, right? And out of those three methods, procedures A, B, and C, procedure A is called within the try block of the main method, and the remaining two methods, procedure B and C, are called outside the try block after the catch block. Okay. So first, let us have a look at what is the content in procedure A, B, and C. So in the procedure A's try block, simply we are displaying a message inside procedure A, and then using the throw keyword, we are throwing an exception. What type of exception you are throwing? Runtime exception, and its description is given as demo, right? And after try block, there is a finally block. There is no catch block. There is a finally block, and in the finally block, you are displaying system.out.println procedure A is finally, right? Similarly, in procedure B also, we have a message system.out.println inside procedure C, and simply we are returning. We are not throwing anything. Unlike we have thrown runtime exception here in the try block of procedure A, we are just returning. Return means where it is going to return, from where this method is called procedure B, to that place you are going to return, right? But even though you write this return statement, there is a finally block here which is displaying system.out.println procedure B is finally. So let me show you by executing this program in the output first. inside procedure A, and procedure A's finally is also executed. Exception caught inside procedure B, procedure B is finally inside procedure C is finally. So all the three finally blocks have been executed, right? But if you look at procedure A's try and finally, in the try block, we have written a message inside procedure A that is displayed first. Okay. Then after that, you are throwing an exception, runtime exception. So this exception must be called from where? Because you are making a call to this A, procedure A, from where? From the try block, right? But do you have a catch block for this try block? You don't have a catch block. So what you're doing is you're catching it in the main method's catch block. And the main method's catch block will display this message, exception caught, right? Then after that, you are making a call to procedure B. But before that, before this exception caught is displayed, if you observe, the finally block that is there in procedure A that has been executed and system.out.println is printing procedure A is finally. So which is first printed? Inside procedure A is printed first, right? And then procedure A is finally is printed. That means what? Even before, even though here exception is thrown, we are not going to the catch block of the main method first. Before that, before going to the catch block, this finally statement is executed, finally block is executed, and then only you are going to the catch block in the main method and executing this catch block. That's the reason why you're getting procedure yes finally first and then exception caught, right? Why? Because once if you come out of this method call without executing this finally, then again you'll never go to that method call procedure A, right? Because procedure A has been called from the main method's try block. So from here the control goes to this procedure A and it gets executed. So when it is executing, it will first execute try, and because the try block is throwing an exception and there is no catch block corresponding to this try block here in this procedure A, so it will go to the, it is just like a nested try block, right? Method nested try block. So the catch block of the calling method will be executed, but even before you go to that catch block of the calling method, this finally will be executed and then only you'll go to that catch block of that main method. Right? Then after this catch block here, you are calling a procedure B, and what is there in procedure B? A try block simply which displays inside procedure B, and then it will return. Return means what? Method return. You have made a call to procedure B, and the try block is not throwing any exception. It is not throwing any exception. Here in the procedure A's try block, we are throwing an exception. But here in procedure B, we are not at all throwing any exception. If you are not throwing any exception, then there is no catch block will not be executed. No need of catch block, right? So even though the catch block is not available for this one, there is no exception thrown here. Inside procedure B will be executed, and after that, procedure B's finally also will be executed. Look at the next two lines. Inside procedure B and procedure B is finally, right? Then you'll come back to this place because the return statement is written. You'll come back to this main method, calling method, and then make a call to procedure C. And in procedure C again, you have try block, which is displaying inside procedure C, and a finally block, which will display procedure C is finally. So both these will be executed, and you'll come back here. So what you need to understand from this is, let me put out here. Finally block must be written after catch block, right? So this is the first thing you need to note, and there is no catch block, then there must be finally block at least, right? So immediately after the try block, if there is no catch block, then finally block must be there. If both of them are not there, there is no catch block and there is no finally block, then it will generate an error. Okay. So this is first point to be noted. These are the two first points, important points to be noted. Finally block must be written after a catch block. Right? If there is no catch block, then there must be a finally block at least. That means what? In place of catch block, there can be a finally block. And then second thing is, there is a catch block and finally block also. Then finally must be after catch. If both catch block and finally block, both of them are there, then you need to write the catch block after the, after you need to write the finally block after the catch block. Fine. The next thing is, finally block will be executed irrespective of whether an exception has occurred or not. Means what? ఎక్సెప్షన్ అక్కర్ అయినా అవ్వకపోయినా ఫైనలీ బ్లాక్ రాస్తే ఫైనలీ బ్లాక్ అనేది కంపల్సరీ ఎగ్జిక్యూట్ అవుతుంది. ఎగ్జిక్యూట్ అవ్వకుండా ఉండదు. క్యాష్ బ్లాక్ అట్లా కాదు. క్యాష్ బ్లాక్ ఎప్పుడు ఎగ్జిక్యూట్ అవుతుంది? ఓన్లీ వెన్ ఎక్సెప్షన్ అక్కర్స్, క్యాష్ బ్లాక్ విల్ బి ఎగ్జిక్యూటెడ్. There is no exception, then the catch block will never be executed, right? But unlike catch block, finally block gets executed irrespective of whether exception occurs or not in the try block. Try block లో అక్కర్ అయినా అవ్వకపోయినా, ఎక్సెప్షన్ అయినా అవ్వకపోయినా ఫైనలీ బ్లాక్ మాత్రం కంపల్సరీగా ఎగ్జిక్యూట్ అవుతుంది. క్యాష్ బ్లాక్ అలా కాదు. ట్రై బ్లాక్ లో ఎక్సెప్షన్ అక్కర్ అయితేనే క్యాష్ బ్లాక్ ఎగ్జిక్యూట్ అవుతుంది, లేకపోతే catch block execute అవ్వదు. Right? So that is the difference between finally block and catch block. So what is the purpose of this finally block means? For example, if you are accessing, if you have opened some resources in the sense your program is accessing a file content which is stored on a hard disk, secondary memory device, or you are accessing a database. So what you will do is, if it is a file, you'll open that file somewhere in the try block or before the try block, right? Or before the exception has occurred, you might have opened a file. But once you open a file, it must be definitely closed. Otherwise, it will be vulnerable, right? So before the exception occurred, if you have opened a file, and after after the statement in which exception is occurring, after that statement, you have a code for closing the file. But what will happen when an exception occurs? The code that is there after the exception line in the try block will not be executed. It will be skipped. It will be skipped, right? So what we need to do is, we need to ensure that the file gets closed even though an exception occurs. So what we need to do, the closing statements, the closing of file that is open, or the closing of database connection that has been established, they must be done within the finally block, because the finally block will be executed irrespective of whether an exception occurs or not. So if exception occurs, then before exiting the try block, the finally block gets executed, right? Before exiting the catch block, the finally block gets executed, and as a result, the resource that is open, that is either file or a database, will be closed, and then only you will exit that method call, or you will exit any program. So to ensure that the resources that have been opened in your program, and there may be a chance that when an exception occurs, if an exception occurs in your program, the resources may not be closed because the code that is responsible for closing those resources is after the statement in the try block where the exception has occurred, because those statements will be skipped. So that statement which is going to close the resource will not be executed. So to avoid such situation, we can use this finally block, and we can write the code corresponding to closing that resources in this finally block, so that you'll not have any problem in closing the files or resources, any other resource. That is the purpose of finally block. Okay, so finally block is used to ensure that any resources that are open can be closed even exception occurs in the program. That is the purpose of finally block, and that is what I have explained till now, right? So how to use this finally block means, just now you have seen. This finally block must be written either after the try block like this. Even if there is no catch block, you can write a try block like this. Or if you have a catch block, then you can write after the catch block also. So let me write a small another program. I'll write a simple program with only one main method. I'll use both catch block as well as finally block. So in the try block, what I'm going to do is I'm going to throw an exception. Shweta, Okay. So exception is thrown and the catch block is executed and it will display finally demo. And after that, in the finally block, we have written after catch. Right. So both catch block and finally block both are executed. So if there is a catch block, then catch block will be executed if an exception is thrown in the try block. If an exception is not thrown, then finally block will be executed directly. If exception is thrown, both catch and finally will be executed, but catch will be executed first and then finally will be executed. So why the name finally? Because it is going to be executed at the end, the last, final గా ఎగ్జిక్యూట్ అవుతుంది. క్యాచ్ ట్రై అయిపోయి క్యాచ్ అయిపోయిన తర్వాత ఫైనల్ గా ఈ బ్లాక్ ఎగ్జిక్యూట్ అవుతుంది కాబట్టి దట్స్ ద రీజన్ వై ద నేమ్ ఇస్ గివెన్ as finally. So finally this block will be executed, right? So in the previous program we didn't use both try catch and finally together for a single try block. We have either used finally block, right, after the try block. Even here also we have used finally only here, but here we have used only catch block. We didn't use both catch and finally together, right? So in this program what we are doing is we are writing catch block as well as finally block. So when there are both catch and finally together after a try block, catch must appear first and then finally must appear last. And if at all, if an exception occurs in the try block, catch block will be executed first and then finally block will be executed last. So that's the reason why when I'm displaying this arithmetic exception, it will display finally demo. And because this is an arithmetic exception, it will display in the output java.lang.arithmetic exception and description is finally demo, right? And after this catch block, finally block gets executed and this will display system.out.println after catch. Okay. So somewhere if you write, you have opened a file, there is a class called file class. You can create an object like this to open a file. In Java, opening a file is different from C language. You can specify a file name here. There is a file called exceptions.ppt x like this. There is a file. So if you want to open that file, then you have to create an object for the class called file class, which is available in java.io package, and create a object for that file. And you use new operator and constructor. For the constructor, you have to mention the file name which you want to open. Then from here, you have to use this object, myfile object, to access the content of the file. So for example, you have opened this file here, and immediately after that, your exception is occurring. If an exception occurs, if there is no finally block, then what will happen? You have written a statement here to close the file. You have written a statement here in this line after throw. You have written a statement to close the file that you have opened here, right? But what will happen? Will the statement which is after the throw statement get executed? It will not be executed. Whenever an exception occurs in a particular line in your try block, all the lines of code that is there after that line will not be executed. They will be skipped if exception does not occur. If exception occurs, if exception does not occur, then there is no issue. The file will be closed definitely because the code which is there after this line will be executed. What if exception occurs? Directly you will go to catch block, right? So that's the reason why, irrespective of whether an exception occurs or not, if you write the code for closing the file in this finally block here, right, this finally block will definitely be executed. Even if exception occurs, it will be executed. Even if exception does not occur also, it will be executed. So in both the cases, the file will be closed, right? So that is the reason why we use this finally block. So let me remove this. Just for your understanding sake, I have written that code. So understood, right?
Yes, sir.
Okay.
హలో సార్, ఒక్కసారి ఫస్ట్ ప్రోగ్రామ్ చూపిస్తారా? అందులో చిన్న క్వెరీ సార్. ఒక్కసారి ఎగ్జిక్యూట్ చేస్తారా సార్ ఫస్ట్ ప్రోగ్రామ్?
first program.
हाँ फर्स्ट प्रोग्राम
Hmm.
సార్ ఒక్కసారి ఇది ఇందులో ప్రోయాక్ ఏని ఎక్స్ప్లెయిన్ చేస్తారా సార్ ఫస్ట్
Procedure A, na?
ఫస్ట్ది
Hmm. So you have defined these methods: procedure A, procedure B, and procedure C, right? But from where you're calling from the main method. And because a main method can call only static methods, we are making them static. If this is not static, then you'll get an error. You cannot call a non-static method from a main method because all these methods are defined in the same class finally demo. The class name is finally demo, and there are 4 methods: procedure A, B, C, and main method. If you are calling these methods which are outside the class, then there is no issue. We can create an object for that class and directly make a call to them. But because these methods are defined within the same class in which the main method is defined, and main method can only call static methods within the same class. It cannot call non-static methods within the same class. So this concept, you have learned it long back, right? So that is the reason why we are defining this procedure A, B, and C as static methods: static void procedure A, static void procedure B, static void procedure C. Why? Because we are calling all the 3 methods from the same main method. So this is the main method. It is beginning here and ending here. So inside main method, we have a try block. First, in the try block, you are calling procedure A, and outside that try block, after catch block, you are calling procedure B and C. So all the 3 methods are made static. That is the reason why we made static. Then uh, first the main method gets executed before procedure A, B, and C. Initially, the program begins execution from the main method, and within the try block, you are making a call to procedure A. Then we'll come to procedure A. And within that procedure A, you are defining a try block. And after try block, instead of catch block, you only have finally block. You don't have a catch block, right? So in the try block, you are displaying first a message inside procedure A, and then you are throwing a exception. So when you throw an exception, the Java runtime system will search for the corresponding catch block. But is there a catch block here? There is no catch block here, right? So what will happen here is, even though there is no catch block, as per the rule, the finally block will definitely be executed, right? So this finally block gets executed before you exit from the method because there is no other code available in this procedure A after the finally block and after the try block. After the try block, you only have finally block. And after finally block, there is no code. The brace is closed for finally block and the brace is also closed for the method definition. So there is no further code available here. So when there is no code, where the control will go? From where did we call this method? There it will go. Right? So we call this method from try block in the main method. So even though the exception that is thrown here is not handled here, it can be handled in the method from where we made a call to this procedure A, right? So we have called this method procedure A from main method's try block. So that means what? You are making a call to that method here, and within this try block, there is another try block in that procedure A, and that will form a nested try block. So when it forms a nested try block, what will happen if the inner try block is not having a corresponding or matching catch block? Then it will search for what? A catch block for outer try block. If that outer try catch block is matching with the exception, then this catch block will be executed. So because there is no catch block here for try block in the procedure A, first, before exiting from this method, the finally block gets executed. Then you'll exit from the method and come back to this try block here in main method. And in this try block, there are no more uh, statements here. And even if there are any statements, they'll not be executed because an exception has occurred in the try block of the procedure A, which is a nested try block. So because it does not have a catch block, it will execute this catch block. So that is the reason why you will get first the output as procedure A is finally, and then after that you will get this message exception caught. That is the reason you will see inside procedure A, and then after that procedure A is finally, right? And after that exception caught. Inside A, procedure A will be displayed within the try block. Then after that procedure A is finally within the finally block, and after that you will come to main method and execute this catch block and display this one exception caught. Then after that procedure B is called. Procedure B has a try block and it does not have any exception. It is not generating any exception. So there is no need of catch block for it. So that's the reason why even though I didn't write catch block here, uh, I'm not getting any error here, right? So then finally block gets executed. Then after procedure B, procedure C is called. Then try block in procedure C gets executed and displays this one, and will return back here after finally gets executed. Procedure C is finally, you'll come back here, and there are no more statements here in the main method. So the program terminates. Understood?
Yes, sir.
Okay. So now that we have seen how to handle exceptions and when to use when to use throws keyword, and when to use finally, all these things we have seen. We have understood the basics, fundamentals. So coming to the next concept, we have a concept of creating our own exception. So that means what? Till now we have been using exceptions that are predefined. Exceptions that are predefined. Java allows us to create our own exceptions in our program. So that we have to see next. So the exception types that we create on our own, they are called as custom exception type. Custom exception type. But before having a look at this program, let me tell you about some other concept related to exception handling. So we have already seen the definition for an exception. What is an exception? What happens? Different keywords, right? What is the advantage of exception? And all these things. But we didn't discuss about this point called types of exception. Exceptions can be classified into two types: unchecked exceptions and checked exceptions. So what do you mean by unchecked exceptions and what do you mean by checked exceptions? That you need to understand. So if you look at the third point here, unchecked exceptions are not checked at compile time, rather they are checked at runtime, right? So all the exceptions that we have that are supported in Java programming are categorized or classified into two kinds of exceptions. One is unchecked exceptions and the other one is checked exceptions. So what are unchecked exceptions means? Those exceptions that are not checked for during compilation, and rather they are checked at runtime. Instead of checking them at compilation, if they are checked for whether there is an exception or not during runtime, then such exceptions are called as runtime exceptions. Okay, and examples for runtime exceptions are: there is a predefined class called runtime exception class and another class called error, and their subclasses. Subclasses means subclasses of runtime exception and subclasses of error class exception. So all these are known as unchecked exceptions. They are all unchecked exceptions. I'll show you the hierarchy totally. And coming to checked exceptions, A checked exception is an exception that occurs at the compile time. These are also called as compile time exceptions, right? Any exception that is occurring during compilation is called as checked exception, and it is also called as compile time exception. These exceptions cannot be simply be ignored at the time of compilation. The programmer should take care of handling these exceptions. Okay, so coming to the hierarchy, I think it is visible, right? So at the top you have a class called throwable class. This is the super class for all the classes, and this class is defined in lang package, java.lang package, which is automatically imported into every Java program. So you need not worry about importing any classes for handling these exceptions in our Java program. So did we import any package in our programs earlier when we were executing these exception handling programs? No, we didn't execute, right? We didn't import any package statements. So even then, our programs worked well because the lang package contains all these classes, and the lang package is automatically imported into every Java program. You need not write an import statement for lang package. But for other packages, you need to write the import statement. So that is the reason why we didn't write the import statements. So in that lang package, you have a class called throwable class, and this throwable class has two subclasses. One is error, and second one is exception. And for this error, we have many subclasses. We are not going to look at this error class because this is related to Java runtime system itself. So the programmer has nothing to do with this. So programmer will not deal with the error class and the exceptions. It is meant for the Java runtime system itself. So that is going to be taken care by the Java runtime system, and we don't have any uh, touch with this. We need not go ahead with this one. We cannot write any programs using these classes for error. And coming to the second branch, exception. Right? So you observe here the yellow color class names which are highlighted with yellow color. They are checked exceptions. Okay. And this orange color are runtime exceptions. This runtime exception is an example for unchecked exception that we have mentioned here, right? So unchecked exceptions are not checked at compile time, rather they are checked at runtime. And runtime exception class and error class, both these and their subclasses together will form unchecked exceptions. So that means what? All those boxes which are mentioned in orange color as well as in uh, pink color error. So these together will form the unchecked exceptions, and the yellow colors will form checked exceptions. So exception class and IO exception, class not found exception, clone not supported exception, end of file exception, file not found exception, malformed URL exception, unknown host exception. All these are called as checked exceptions, right? But look at this throwable class. It has two subclasses, error, and we are not concerned with this error and its subclasses. Coming to the second subclass, that is exception, which is in yellow color, which means it is a checked exception. This exception class has how many subclasses? These are all subclasses. There will be multiple subclasses here in this here for this class, and one of the subclass for exception is IO exception. Second one is class not found exception, and then clone not found exception. So we didn't deal with these yellow color classes till now. And apart from this, you have this orange color runtime exception. For this runtime exception, you have a subclass: arithmetic exception, class not found exception, illegal argument exception, right? Illegal state exception, index out of bounds exception. And for this index out of bounds exception, we have a subclass array index out of bounds exception, null pointer exception. And for illegal argument exception, you have number format exception also. So we have been dealing with only these orange type of classes only in our programs. So what are these orange type of exceptions? They are runtime exception. They are subclasses of runtime exception, and they come under which category? They come under unchecked exceptions, right? So till now, what we have been handling is unchecked exceptions. We have been handling unchecked exceptions like runtime exceptions subclasses, all the subclasses. And again, runtime exception is a subclass for exception class. So that is the reason why I told you in the cache block, if you are using exception, then this will cover runtime exception and all its subclasses. So if you don't know exactly which exception is going to occur, what kind of exception is going to occur, what kind of runtime exception is going to occur in our program, then in the cache block, you have to mention this superclass exception, so that this is going to handle any type of exception which is a subclass for this exception class. It is going to handle these things, even these things, right? If you know specifically arithmetic exception is going to occur, then you can use arithmetic exception in the cache block. If you know specifically that array index out of bounds exception is going to occur, then you can use it directly. But if you're not sure which one is going to happen, then you can give uh, this superclass exception in the cache block, so that it is going to handle any type of exception that is subclass for this exception class. So what you need to understand here is checked exceptions and unchecked exceptions. What are unchecked exceptions? Unchecked exceptions are not checked at compile time. That means that is what I mentioned, right? Even though you make any exception, you create an exception in your program, any unchecked exception, it will not be handled during compile time. So during compilation, you will not get any error. When you are going to get an error during runtime, right? So rather they are checked for at runtime. So that's why compilation will be done without any issue, and when you run the program, exception will be generated. So such exceptions are called as unchecked exceptions. If your exception is not handled during compilation and if it is handled during runtime, we call that exception as a unchecked exception. And what are the list of unchecked exceptions in our hierarchy means all the subclasses which are all the classes which are subclasses for runtime exception and error class are all unchecked exceptions. Okay, and coming to checked exceptions, these exceptions will be checked for during compilation itself, right? So they will be checked for exceptions during compilation. So these exceptions cannot simply be ignored at the time of compilation. It is the responsibility of the programmer to take care of handling these exceptions and write the code properly, because they will be checked during compilation itself. They will not be handled during runtime. They will be handled during compilation. So the programmer himself has to take care of handling these exceptions by writing the program in a proper way without making any okay. So and the rest of the thing, this is all syntax for try, catch, throws, and finally first try block will be there. Then after that catch block, and after that you can have another catch block. You can have as many catch block as well. And finally, after all catch blocks, you will have a finally block. So how the try exception handling mechanism works? First, the try. This is the flow chart which will show you how the try, catch, and finally mechanism works. So if a try block is executed and if the code may throw or may not throw exception. If it throws an exception, then it means yes, you will go to catch block. If an exception is not thrown, you will go to directly finally block. If an exception is thrown, you'll go to catch block, and after catch block, you'll again come back to finally block. Right. So irrespective of whether exception occurs or not, finally block will definitely be executed. But catch block may or may not be executed. Only if exception occurs, then only catch block gets executed. Otherwise, it will not be executed. Okay. So if you want, I'll send this PPT to you. So the place of programs we have already seen practically by all the concept that I explained during the programs that I explained you will be explained theoretically in these slides, right? Along with programs and their outputs will be shown here. All the nested try statement, throw statement, those their syntax, everything will be there. I'll send you this PPT. Okay. So
Okay, sir.
now, yeah. So now that you have seen how to create these exceptions. These are all the built-in exceptions and unchecked runtime exceptions. Arithmetic exception, array index out of bounds exception, class cast exception, illegal argument exception. Because we cannot accommodate all these class names in that slide where we have mentioned the hierarchy using a diagram. So the list is mentioned here in this slide, and when these exceptions will be occurred. And these are list of checked exceptions. Right? And these are some of the methods defined in probable class. And we are not using all the classes. We have used only print stack trace method, right? So there are multiple versions for this print stack trace method because it is an overloaded method, right? There is a method called init cost method, and get message, get localized message, and you can get a stack trace in the form of an array. That also is there. So, but we will not be using practically in all in any real-time applications. We are not going to use these methods. So that's why we can ignore them. When it is required, we can use it. Generally, we don't use these methods. So we'll only use this stack trace method, print stack trace method, to know about the complete exception stack, right? Where the exception has occurred in which line, from where we have reached to that particular code. Everything, if you want to know, you'll use this single print stack trace method. So the thing that we need to discuss finally after the finally block is user-defined exceptions. All these exceptions that we have seen earlier, they are all predefined exceptions. That means the Java is providing us with that exception. But what if I want to create my own type of exception? Arithmetic exception ఎట్లా అయితే ఉందో యూజర్ డిఫైన్డ్ ఎక్సెప్షన్, అలాగే ఏదో ఒక నా సొంతగా నేను ఒక ఎక్సెప్షన్ టైప్ ఒకటి డిఫైన్ చేసుకోవాలంటే దట్ ఈస్ ఆల్సో పాసిబుల్. You can create our own exception in our program. So how to do that? How to create your own kind of exception? So we'll see with this example program. So if you look at this class, if you look at this program, there are two classes. First one is my exception. Second one is exception demo. This exception demo consists of the main method, right? Java. Because the main method is defined here in this, we need to save it as exception demo. So if you look at this first class, my exception, so this class is the exception class that I'm creating on my own, right? So just like arithmetic exception, array index out of bounds exception, null pointer exception, class not found exception, which are all built-in exception types classes, we can create our own user-defined exception class also. So my user-defined exception class that I'm creating in this program is this one, my exception. So in order to create a class and make it a user-defined exception, we need to make that class as subclass for exception class. So in the hierarchy, we have seen the exception class, right? In our probable, you have two subclasses. One is error and the second one is exception, right? So we need to create a subclass for that exception class in our program, right? So after making a subclass like this, what I'm doing here is I'm declaring an integer variable with its name as the detailed, and it is made private. So I can access this private variable only within this my exception class. I cannot access it outside this class. And we are defining a constructor for this class. and which receives one integer parameter, and the parameter a that is passed to this constructor is assigned to the instance variable detail. Then we are defining a toString method. This toString method, what is it going to do? I didn't show you this toString method. So in this print stack trace method and all, at the last we have seen, there is a method called toString method whose return type is string. Means what? When you call this toString method, it is going to return a value, and that return value will be a string value. So that is the reason the return type of this method is given as string. What is this method going to do? It returns a string object containing a description of the exception. This method is called by println when outputting a throwable object, right? So throwable object means what? Any class which is either any object which is a object for either throwable class or the subclass of throwable. Subclass of throwable means error is a subclass, exception is a subclass. And again, exception has some other subclasses. So all those classes can be called as throwable objects. Any object of all those classes is called as a throwable object, right? So what is this toString method going to do is it is going to return a string object which contains a description of the exception that has occurred. But what we are doing here is, and I mentioned clearly that this toString method, where is it defined? It is defined in throwable class, and we are creating our myException class as subclass for which class? Exception class, and throwable is a superclass for exception. So that means the toString method which is defined in throwable class will also be defined in exception class, right? And because exception is made a subclass for myException, so the toString method is also part of this myException class now. But what I am doing here, I am redefining the toString method once again here, right? So that means what I am doing, I am overriding the actual version of toString method which is part of exception class, right? So in the subclass, if you define the superclass method once again with the same type signature, what is it called as? The process is called as overriding, right? Overloading is different. Overloading will not have the same type signature. Instead, it will have a different type signature. The method name will be same, but signature will be different. But coming to overriding, the subclass will have the same method with along with its same name and same parameters, type of parameters and return type. Everything will be same, right? So here I am overriding the toString method. Why I need this toString method? Because this toString method is going to return the description about the uh, exception that has occurred. And when it is going to throw, it is mentioned here, returns a string object containing a description of the exception. This method is called by whom? Println method, that is system.out.println method that we are using, right? So whenever you make a call to that println method, automatically that will make a call to toString method, and the toString method is going to return this description about this exception. Okay, so this toString method, what is it doing? It is returning my exception and open a square bracket and close the double quote. So till here it will be displayed as it is, and this will be concatenated with what? The value of detail. So whatever value you pass to detail, that is a, that will be displayed here, and that in turn will be concatenated with this closing of square bracket. So this is what you're going to get. Say for example, if a is given as 10, then it is going to display my exception and within the square brackets the value of 10, right? So that is how this class is defined. Now in exception demo, I am defining one more compute method which is static and return type is void. Because why I made this as static? Because we are defining it in the same class in which the main method is defined, and the main method is going to make a call to this compute method. So if it has to call this compute method, then this compute method must be definitely a static method, right? And for this compute method, what I am using is throws keyword. So you know when to use throws keyword. If a method is not capable of handling if it is capable of generating exception, but it is not capable of handling that exception, then this throws keyword will inform to those calling methods, whichever method is making a call to this compute method, it will inform that method to handle that exception by itself. So then whichever method is making a call to this compute method, it has to make that call within a try block, right? So that's the reason why I'm mentioning here throws. And what type of exception it is throwing? My user defined exception that I created here, right? So I'm mentioning my exception here. And within this compute method, I'm displaying system.out.println called compute, right? With the value a. What is the value a? It is a parameter passed to this compute method. And if the value of a is greater than 10, then you are throwing your exception now, right? What type of exception? My exception that we created earlier. And we are passing what? A as parameter to the constructor, because this constructor receives an integer parameter, right? And then after that, system.out.println normal exit. Then you are making a call to this compute method from where? From within the main method's try block here. You're first initially making a call to the compute method with 1 as parameter, then second time with 20 as parameter. Why I've called it 2 times means because the once I'm giving a value less than 10 and second time I'm giving a value greater than 10. So when this exception will be created and thrown only when the value of a is greater than 10. If the value of a is less than 10, this statement will never be executed. So if this is not executed, then this statement will directly be executed and it will display normal exit, right? So this I have put in try block. Why I'm putting this in try block? Because this compute method is actually going to generate an exception and throw that exception, but it is not going to handle that exception. So we have mentioned it as throws my exception. And who has to handle this exception? Whichever method is calling that compute method. So who is calling? The main method is calling. So in the main method, when you make a call to this compute method, you enclose these statements in the try block. Then define the corresponding catch block. In catch block, here I'm mentioning the exception type as my exception E. And I'm making a call to system.out.println and it will display caught concatenated with E. So what is E? E is nothing but the value returned by the toString method. So what is toString returning? It is returning this my exception detail. So if you execute this program now, so called compute with 1, so normal exit type without exception. Exception did not occur. But when you called compute with 20, exception occur and it has been caught with my exception 20, right? So this is how you can create your own exception. Instead of integer parameter, you can pass a string parameter also. Okay. So instead of passing integer parameter, you can create this exception constructor with a string parameter. Normally, the built-in exception classes will have a string parameter for their constructors, right? So when we created in the previous programs, so what is that we mentioned for exceptions? Throw new runtime exception. In the constructor, we have given a string message. But in our built-in exception that we created now, instead of string, we have passed integer parameter. So even here also, when you are throwing my exception, which value you are passing a, where a is nothing but an integer, right? So you are passing Yeah. So instead of passing this integer values, you can create your an exception by passing a string value also. So if that is the case, then here you need to create a string parameter here, and that string parameter description can be assigned to this variable. This also must be made a string variable, and you can return that string value here. In place of this integer value detail, you can return. No need to display this one also. Directly you can return the detail value. So whatever description you give, that description will be uh, printed here. When system.out.println. So when you are making a call to println, this is going to make a call to toString method automatically. You need not make a call to toString method. This will be automatically called. So did we make any call to toString method here? We didn't make. We are making a call only to the println method. So this println will in turn make a call to toString method. Okay, understood?
Yes, sir. Hello.
So
Yes, sir. అర్థమైంది సార్.
okay, now your task is for tomorrow. You do all the pending works, at least related to the exception handling. ఒక ప్రీవియస్ ఎక్సెప్షన్ హ్యాండ్లింగ్ ఇవన్నీ క్లాసెస్ మీద చేసినవన్నీ కూడా అన్నీ ఒకసారి రివైజ్ చేసుకొని ప్రోగ్రామ్స్ ట్రై చేయి, ఎగ్జిక్యూట్ చేయి సొంతగా. ఒక బిల్ట్ ఇన్ ఎక్సెప్షన్ కాకుండా యువర్ ఓన్ ఎక్సెప్షన్, సొంతగా నువ్వు ఒక ఎక్సెప్షన్ ఇట్లా క్రియేట్ చేసి ప్రోగ్రామ్ చేయి. ఇది కంప్లీట్ చేసుకుంటే విల్ గో హెడ్ విత్ నెక్స్ట్ టాపిక్. కొత్త టాపిక్ ఏంటంటే మల్టీ థ్రెడింగ్. జావాలో మల్టీ థ్రెడింగ్ అనే కాన్సెప్ట్ ఉంటుంది. ఆ టాపిక్ స్టార్ట్ చేసుకుందాం రేపు.
ఓకే సార్.
విల్ మీట్ టుమారో మార్నింగ్.
ఓకే సార్.